All right, here's our problem set. So we're going to read this, and then I'm going to walk you through this and how it's done, okay? So here we go. The chart to the right shows the distance fourth graders in Mrs. Smith's class were able to run before stopping for a rest. All right. Every time I come to a period, I'm going to stop and think about it. All right, so they were, chart shows the right distance fourth graders could run. Okay. Wow, that's pretty cool. These are high numbers. All right. Create a line plot to display the data in the table. All right, I'm going to look at the data first, okay? And I'm going to see these are all mixed numbers. All right, I can see the names of the students here, and this is the distance that they ran. So the chart makes sense to me, and that's important. All right, now I'm going to look at the fractions because I want to compare these, right, just in my head to see if 2, 4, eighths, fourths, eighths, eighths, and eighths. Do you see how all, like 2, 4, and eighths are all related to one another, all even numbers? I can easily try to compare those, all right? And we're going to use a number line to compare it because a number line is a line plot, okay? So I'm going to zoom out here, and I'm going to raise this up a little bit so we can see how the line plot's going to be done, okay? So the first thing I'm going to do is draw my line. So down here at the bottom, okay, I want to leave some room up top. I'm going to draw a line that goes across my page. I'm going to just get it all the way across here a little bit. All right. So then put an arrow on either side, okay? At any point, teachers, just feel free to pause and let kids catch up, okay? But I'm going to keep rolling. Now what I need to do is figure out, all right, what is the name of my line plot? You know, you always want to name it like you have, you name your graphs and stuff, so we did in third grade, all right? And what we're going to do is label this up here. We're going to say, I don't get the distance, fourth graders ran. Okay, I'm going to capitalize the G and the R in a title. All right, that's what Mrs. Countryman told us to do. Graders ran. Good. All right, so here we go. Now, what I need to do is figure out where my line plot needs to be by looking at my numbers, okay? So it needs, where does it start and where does it end? And I notice that all of these numbers come between 0 and 3. Would we agree with that? Yeah, all comes between 0 and 3. There's a few lower ones. Look at this one's 5/8. This one's really low, so I need to have, you know, start way low. And it doesn't, none of these go above 3. So I know my starting point will be down here as 0. So I'm just going to label this as 0, okay? And my ending point over here is going to be 3. So then in my line plot, I'm going to put in all these fractions, okay? And what we're going to do is make something very similar to what you see here. This is a tape measure. And you can see on the tape measure that I've got lines, all these lines represent fractions, and you can see some lines are bigger than others. Like the halfway point is a bigger line, and then half of the halves are a little bit smaller, and then you get a little bit smaller from there, okay? The smaller the measurement, the smaller the line, essentially. And that's what we're going to do, okay? So now in between the number line, the next step I want to do is put in the whole numbers, okay? So I know I'm missing the whole number 1 and 2. So I'm going to make those nice and even, right? Here's the whole number of 1, and here's the whole number of 2. Okay. So now I've got 0, 1, 2, 3. Perfect. All right? And I can tell, like, you see these two are a little closer, but I'm doing this freehand, so we're okay. So the first thing I want to do is label, because I look at my fractions here, I want to label or find the halfway point. See how I have a half right here? So that's important. So what I'll do is find the halfway point. So my whole numbers are big lines, okay, like that. And my halfway point, I'm going to make a little bit smaller, but still big, of each one, halfway. Okay? So there's my halfway points. See how they're all there? Okay, and I don't need to label them I'm just making, just like I talked to you about before. You see, I'm making I made the halfway points, all right, of each of these, all right? So you see we start the 0, halfway, 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 okay? So now what I'm gonna do is do my next smallest fraction, which is, if I look back at my data, I see it's fourths. So I know how to make fourths out of halves. So again, I'm gonna make this line, I'm gonna cut the halves in half and make the line just a little bit smaller, okay? So I know that those are quarters, right? Those are 1/4. Okay, just like that. Kind of like making plan plots or number lines. Good, so I need these a little bit smaller. And then finally, I look back at my data, I noticed that the smallest unit I have is eighths, right? So now I need to make eighths out of all this, and those hash marks are gonna even be smaller. So eighths are half of the fourths. So I'm just gonna do little marks like that. Just like that, okay? And you can see that I've made something similar to my tape measure and something similar to what you see on your own rulers. Those long and short lines, those are what they stand for, okay? So you can see on my ruler, I got those long and short lines going across. They mean something, okay? And just like here, the whole numbers have the biggest line, the halves are a little bit smaller, the quarters are a little bit smaller than that, the eighths are a little bit smaller than that. If I went to the 16ths, it'd be even tinier, okay? So the smaller the measurement, the smaller the little hash mark on the line, okay? So now I've got a nice number line all laid out for me, which is great. Now what I can do is plot my data, all right? Plot my data. First, I need to label what this number line represents, all right? It represents distance, okay? It represents the distance in miles. So that's what I'm going to do there. I'm going to represent distance. Let me write this down. Distance in miles. Okay? Perfect. So now a line plot, you have to plot the measurements with an X, all right? So we're going to create that line plot, so an X. So down here are X's. Let's write this down. X's will equal 1 student. Okay. So I'm going to look up here and find Joe. Joe went 2.5 miles. So I'm going to put an X over that spot, okay? So I'm going to find 2.5 miles. So there's 2 and there's a half, right? So I'm going to put 1 X right there. See that? Above it. Good. And I try to make my X's about the same size every single time. Okay, it's important that we do that. All right. Then I look down here, so I put a check mark next to that one so I know I did it. Ariana is 1 3/4. Okay, check mark, 1 3/4. So I'm going to go down here and find 1 3/4. Now I have to remember that these are the fourths, right? 1, 2, 3. Right? Halfway is 2/4, right? So this would be my 3/4. So I'm going to put a nice X over the top of that. Okay? Remember, same size X. So it's super important that we remember that. Okay? I get kids that, will do just like a huge X and a small X. We don't want to see that. We want to look nice and neat here, okay? All right, the next one is Bobby, and that's she or he is 2 1/8. So I'm going to get to my 2. Here's my 2. And then 1/8 is my first little mark there. It's an eighth. Okay, so I'm going to put the same size X right there. Good. Oh, I forgot to check it off up here too. So I'll do that, make sure I did that. Morgan is 1 5/8. Okay, so let's check out where Morgan is. 1 5/8. Okay, check her off. 1 5/8. So I'm going to count up 5 here. 1, 2, 3, 4. Say 1, 2, 3, 4, 5. There we go. 1 5/8. Great. Same size X's. Then I've got Jack at 2 5/8. Okay, so 2 5/8. So 2 5/8. 1, 2, 3, 4, 5. There we go. So these are all marking on the line plot where these kids are. Okay. And then, but I'll go back and label those after. I got Saisha is 2 1/4. So here's 2 1/4. Remember, 1/4 was this half of the half? So I'm going to write that down. Okay. And then Tyler is 2 2/4. So that's what I'm going to do is Tyler at 2 2/4. 2 2/4. There's 1/4. There's 2/4. Oh, there's already an X there. Well, you know what we do? We stack up another one. So 2 2/4 is equal to the 2 1/2 that we first plotted. Again, same size X. Now I can look at it and I can see that there's 2 X's. You see how it's a little higher there? It kind of sticks out. And then I've got Jenny, which is 5/8. So she's way down here, okay? Jenny's 5/8, so I got 0, 1, 2, 3, 4, 5. Jenny's what we call an outlier. The data was way off from the other data, okay? Then I got Anson, which is 2 2/8. So come down here, 2 2/8, 1, 2. Oh, another X goes on top. There. Those two are the same size. And then finally, Chandra, or Chandra, 2 4/8. That's 2 4/8. 1, 2, 3, 4. Ooh, that one's a pretty popular measurement. Okay, there. So 3 X's there. So we just created a line plot. All right, now going through, I could label each one of these. All right, about the distance of each one. You don't have to, but if you did, I would label it down here. Like this one was 5/8. Okay, this one here was 1 5/8. Okay, but you see, if you start labeling, they're going to get really messy up here. Okay. All right, so now I've got my data all written out here, and I can tell that most of the kids here ran 2.5 miles. Okay, they were just represented in different ways. I can see that 2.5 here, and 2 2/4 there, and 2 4/8 there, all equal to 2.5. Okay, good. So we did this. Now let's answer the questions on the back. It says, who ran a mile further than Jenny? Okay, so here's Jenny. Jenny is 5/8. So 1 mile further, 1 5/8, right? Would have to be that. So here's Jenny is 5/8. So I'd have to add 1 mile to it. So who ran 1 5/8? And it sticks right out to me. Kid in my class, 1 5/8. Morgan. Okay, so Morgan. Morgan ran 1 mile farther than Jenny. Good, there. Who ran 1 mile less than Jack? Okay, again, teachers, pause at any time, okay? I'm gonna keep pushing through, okay? Who ran a mile less than Jack? So Jack is here, 2 5/8, so 1 mile less than 2 5/8. I just subtract 1 off the 2. It'd be 1 5/8. So where's my 1 5/8? There. Oh, Morgan again. Morgan's pretty popular. Okay. So Morgan ran 1 mile less than Jack. Period. Okay. And then 2 students ran exactly 2 1/4 miles. Identify the students. How many quarter miles did each student run? Okay, so we've got like a 2-part question here. So we got to identify 2 students that ran exactly 2 1/4. So let's come down here. 2 1/4. So here's 2 and there's 1/4. So you see we've got that 2 X's right on there, okay? So I'm going to take a look at find 2 1/4 anywhere. So here's 2 1/4. So there's 1. Saisha, right? So Saisha ran 2 1/4. Now, what other fraction is equivalent to 1/4? Let's see, 2 2/8, right? See that? 1, 2. And that would be Anson right here, okay? So both Anson and Saisha ran 2 1/4 miles. All right, so I'm going to answer the first part here. Saisha and Anson ran 2 1/4 miles. Period. Okay, so it says how many quarter miles did each student run? Okay, so it wants me to put this into a fraction greater than 1. So I've got to convert this to all quarters. And remember how to do that? So we'll say 2 1/4. I'll rewrite it over here. So remember, 4 times 2 is 8, plus 1 is 9, and then 4s remain the same. So it's 9/4 or 9 quarters, okay? So they ran, let me write that down here. They ran 9/4 miles, or 9 quarters, okay? All right, what's the difference in miles between the longest and shortest distance run, okay? So the difference means subtraction, right? So we need to do that down here. So the longest and the shortest, okay? So let's take a look. The longest distance run was, let's see, way up here. And that was 2 5/8. So who was 2 5/8? That was Jack. That was the longest distance. So 2 5/8. And the shortest distance, that one sticks right out to me, right? This one was way down here. It's just 5/8. Okay? So 2 5/8 and 5/8. Okay? So the difference, 2 5/8 minus 5/8. Okay. So guess what that equals? Equals just 2, right? If I have 2 5/8 and I subtract the 5/8, I just have 2 miles left. So 2 miles is my answer, okay? So the difference between the longest and shortest distance run is 2 miles. Period. Okay. All right, it says compare the distances run by Ariana and Morgan using greater than, less than, or equal to. So Ariana and Morgan, okay, let's go and find those two. So Ariana is 1 3/4 and Morgan is 1 5/8. Okay, so 1 3/4. I'm going to compare that to 1 5/8. Okay, so I'm going to compare that. So we just did this a lot over the past couple days. 1 and 1 are the same. Then I look at 3/4 and 5/8. I see that 4ths and 8ths are related, aren't they? Right. So if I convert this fraction to 8ths, what I'm going to end up with is 6/8, correct? Because I just multiply the numerator and the denominator by 2, get an equivalent fraction. And I can see that 6/8 is just a bit higher than 5/8. So 1 3/4 is greater than 1 5/8. Okay? Okay, so it looks like Ariana ran just a little bit further. Okay. Mrs. Smith ran twice as far as Jenny. How far did Mrs. Smith run? Write your distance as a mixed number. Okay, so whole number and fraction. So Mrs. Smith ran twice as far as Jenny. So we're going to multiply that by 2. Okay, so Jenny, how far did Jenny run? 1 Is that right? No, Jenny is 5/8. That wasn't 1. So she was ran the less, so 5/8. So I need to double my 5/8. So I need to, see, Jenny ran 5/8. I need to multiply that by 2. Okay, so if you remember, when you multiply by 2, all you do is just multiply the numerator, just double that, right? Because 2 as a whole number looks like this. 2 times 5 is 10, 1 times 8 is 8. So this is equal to 10/8. But it says write my distance as a mixed number. Okay, so Mrs. Smith Ms. Smith ran, see, 8 goes in there, 1 and 2/8 miles. I could have said 1 and 1/4 mile too. All right, now, Mr. Reynolds ran 1 3/10 miles. Use greater than, less than, or equal to compare the distance Mr. Reynolds ran to the distance that Mrs. Smith ran, okay? So, Mr. Reynolds is 1 3/10. And I got to compare that to what Mrs. Smith ran, which is right here, 1 2/8. So I compare my whole numbers first. 1 and 1, they're the same. So now I look at 3/10 and 2/8. Well, those aren't related facts, are they? They're not. So what I'm going to do is create a cross multiplication sheet over here. I'm going to do this, 3/10 and 2/8, just to compare these fractions on the end. 10 times 2 is 20. 8 times 3 is 24. Yeah, just a little bit bigger, right? Just double check my work. 8 times 2 is 20. 10 times 2 is 20. 8 times 3 is 24. Good. So it looks like Mr. Reynolds ran just a bit further. So who ran further? Mr. Reynolds. If you can see that or not. Reynolds. Not a lot of room to write down here. Ran farther. Period. Okay, so using the information on the table on the line plot, develop and write a question similar to those above. Solve and then ask your partner to solve the question, okay? That last one is completely up to you teachers, all right? I've already been on this lesson for too long, so if you want to create a problem for this using the line plot, be my guest. Other than that, great job today, all right? Nice job with this line plot. It's actually a lot of fun, isn't it? Yeah. All right, guys, we'll see you tomorrow.